In this video, I'll be talking about modeling with systems of linear equations. We did an example similar to this in class on Tuesday. Off the top of my head, I'm blanking on what the example was about. It was where we looked at the two linear equations and we found their point of intersection, and that gave us important information about the relationship in the system. So when we talk about modeling with system of linear equations, if you recall, a system of linear equations is two linear equations that can be graphed, and when you solve a system of linear equations, you're looking for the point of intersection of the two lines, or the point that makes both equations true, or I guess I should say and makes both equations true. So one very common problem that we see with systems of equations is revenue and cost functions. So the revenue function, so revenue and cost, let's read this one first. A company produces and sells X units of a product. Its revenue is the money generated by selling X units of the product, and its cost is the cost of producing X units of the product. So your revenue is simply however much you charge for each item that you sell times the number of items that you sell. So X is the number of units So the price per unit sold times the number of units. The cost is your fixed cost. Now, this fixed cost could range from anything such as your monthly rent or upkeep on equipment or anything like that. So this cost is your fixed cost. It's your constant value. It doesn't have a variable with it. So then plus your cost, so this is your fixed cost, and then your cost per unit produced. So it will cost a certain amount for every item that you produce. Okay, so I think it'll make more sense when we look at an actual example. Alright, so we have a company that manufactures running shoes. They have a fixed cost of $300,000. Additionally, it costs $30 to produce each pair of shoes. So this is again part of the cost function. They are sold at $80 per pair. So this is going to be part of our revenue function. And this information is going to be part of our cost function. So again, they're selling running shoes. And let's look at our cost. Our cost, C of X, we write this in function notation, is our fixed amount, our fixed cost, which is in this case $300,000, and like I said, that could be rent, that could be upkeep of equipment, that could be the cost of employees. That's what you have to pay every month or every financial period that we're calculating for here. Additionally, so along with that $300,000, we also have to pay, or it also costs $30 per pair of shoes. So we're going to have to add on $30 per pair of shoes. And that's our cost function. So your cost function will always have two terms like that. And your revenue function is a little bit more straightforward because your revenue is just how much money you make when you sell a pair of shoes. So your revenue for X, with X being the number of shoes that you sell, is just however much you make per pair. So it's $80 per pair. Now, let's talk about what it means to break even. Break even is when your costs, so how much money you're actually putting out to manufacture these shoes, is equal to your revenue. So how much money you're actually bringing in, and that's your break-even point. So hopefully when you are producing something such as running shoes, you will meet your break-even point, but ideally we will go beyond our break-even point, and at that point we actually make a profit. So if we want to find the break-even point, we're simply looking for where your cost function equals to your revenue function. And your cost function here is 300,000 plus 30x, and your revenue function is 80. x. So we can set these equal to each other. And when we do this, we can solve by subtracting 30x here and subtracting 30x here. And we get 300,000 equals to 50x. Divide both sides by 50. And x is, so this is 300,000 divided by 50, and x is 6,000. Okay, so let's talk about that. So the break-even point, let's go ahead and find that ordered pair. So x is the number of, so we would have 6,000 pairs of running shoes. And this is when we would break even. So to break even. So we'd have to make 6,000 pairs of running shoes and sell 6,000 pairs of running shoes in order for us to break even. So now let's go back and substitute that back into one of these equations. Either one, either your cost function or your revenue function. It does not matter because this is the first thing we did. Now we're going to go back and substitute. It doesn't matter which one because remember you found the value that makes these two equations equal. So if I go back and substitute, my revenue when I sell 6,000 shoes is 80 times 6,000. And when I calculate that, I get 480,000. Now, just to be on the safe side, I'm going to calculate my cost at 6,000. And so that's going to be 300,000 plus 30 times x, and x being 6,000, running out of room there. So it's going to be 300 plus 30 times 6,000, and that is indeed 480,000. And if I had gotten something different, I know that I would have made a mistake because, again, your break-even point is where cost equals your revenue. Now, so if I were to ask you here, how many shoes do I need to sell to make a profit? I would simply need to sell 6,001 shoes because that would give me more revenue than cost. Alright, so here 6,000 pairs, so my actual break-even point is when x is 6,000 and y is 480,000. And if you want to describe what that means, when you sell, so if you sell, or if we sell 6,000 running shoes, we will break even. In other words, our revenue will equal our cost. Okay. Let's talk about our profit function. So the profit function, our profit, is generated after producing and selling X units of a product. Our product is given by the profit function. So your product, your profit is your revenue, so how much you're bringing in minus your cost. And you want this to be positive. If your profit function is 0, then that means you are making, you're breaking even. So if revenue is equal to cost, then you would break even. So R and C are the revenue and cost functions. So if we are asked to write a profit function for the running shoe business in the previous example, let's go back here. We need to remember these here. Our cost function is 300,000 plus 30x. So cost is 300,000 plus 30x. And our revenue function is, what was that, 80,000? Or excuse me, 80x, because it cost $80 per shoe. Yes. So our profit function is going to be our revenue, which is 80, minus our cost, which is 300,000, plus 30x. And the reason that I put this in parentheses is because I want to distribute that negative because we're subtracting this entire expression. So that's going to give me 80x minus 300,000 minus 30x, distributing that negative. 80x minus 30x is 50x minus 300,000. And so my profit function is 50 times however many I sell, make and sell, I guess I should say, minus 300,000, which makes sense because my revenue is 80, my cost per shoe is 30, so my revenue is technically going to be only, or the amount that I'm going to actually make is only going to be 50 times what I bring in, but I still have to subtract out that fixed cost of 300,000. Now if I put in what is my profit at 6,000, hopefully in your head you're thinking what should happen. And because we found that 6,000 was our break-even point, our profit should be equal to 0 at this point. And it is indeed. At 600 it is 0. Okay, so for this example, we're asked in the problem below to write the cost function, the revenue function, and determine the break-even function, the break-even point. So I want to do this, and then I want to tack on part D, where you can use your graphing calculator to check your answer. So the company that manufactures small canoes has a fixed cost, so this is going to be part of our C function. This is fixed of 18,000. It costs, so this is more of our cost function, $20 to produce each canoe. The selling price, so this is going to be our revenue, is $80 per canoe. Okay, so the first thing we have to do is come up with our cost function. And our cost function is our fixed amount, which is 18,000. That does not change, plus $20 per canoe. Alright, and then the selling price, so our revenue, we're going to get, because we're going to make $80 per canoe. We get our break even when our cost function, so our break even is when our cost function equals our revenue. So 18,000 plus, oops, sorry about that. So 18,000 plus 20x, when this is equal to 80x. I'm going to subtract 20x from both sides because now we just have an algebraic equation, and we get 18,000 is equal to 60x divided by 60, and x is going to be 300. It's late, so I'm just going to make sure my math is correct, is 300. So x, remember, x is the number of canoes bought or made or sold canoes. So if we make and sell 300 canoes, we will break even. So I would say, let me make that a complete sentence. If we make and sell 300 canoes, we will break even. And that break even point, if I go back in here and substitute in 300 here, that's going to give me $18,600. And hopefully if I substitute it in here, oops, sorry, that should be a 300. My bad. 18, 1, 2, 3 plus 20 times 300. That makes more sense. I was about to panic because my numbers weren't going to match. So that's going to be 24,000. And if I come in here and I substitute 300 here, it also gives me my 24,000. So I get my break-even point is when I make and sell 300 canoes, and at that point the cost and revenue will be $24,000. Now what I want you to see is how we can look at this in the graphing calculator. And so I'm going to have to, whoops, let's see. So if I come back here and I pull up my calculator, I can come in here and I can go to my y equals and I can type in my cost function, which is 18,000 plus 20x, and I can type in my revenue function, which is 80x. And hopefully you can already see that I'm going to need to change my windows and make them really large. My y-intercept of my first equation is 18,000. Remember your slope-intercept form, my slope being 20, so I'm going to need to make my y values, like let's go ahead and make my x-min -10, my x-max, and we're looking at x is 300, so let's make x-max 500. Your y-min, I'm going to leave it at -10, but we really don't need to deal with our negative numbers because we're looking at, well, I guess you can look at your, well, if we were looking at profit, we would be looking at negative numbers, but your cost and your revenue will not be negative. It could be 0, but it won't be negative. So let's make your y max, let's make that 30,000. And when I graph these, you can see up here we're starting, we're not starting at 0, 0. This function's starting at 0, 0. So we know our red line is our revenue because it's 80x. It doesn't have a, the y-intercept is 0. And this function right here is your cost function because we're already starting at 18,000, but we're increasing only by 20x. So then we're going to find our point of intersection. So I'm going to go to second, calculate. I'm going to calculate 5, so I'm going to select 5, which is your intersection. And we can hit enter, enter, and it gives us an opportunity to guess, and we don't want to guess, we want the actual information. And your intersection is when x is 300 and y is 24,000. Now, you will not be required to do this with your graphing calculator. I'm just showing you how you can use graphing, and hopefully this helps you also understand a little bit better about what it means to solve your system of equations.